Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, we're going to look at question 10 under Euclidean Geometry. So it goes as follows. In the diagram below, O is the center. I have the center. O is the center of the circle, right? And of the circle ABP, all right? We are also told that PB is extended to C. I don't think that information is necessary. It is necessary, but for the purpose of calculation, AC is drawn. PN is a tangent to the circle at P. This is the information that I highlight. OC intersects AP perpendicularly. This information is important at point A. Remember, intersect and bisect is not the same. Intersect means they meet. Bisect means it cuts into equal angles. Then P2 is equal to 37 we are given. All right. Now, without even looking at the question, sorry about that. Without looking at the question, let's try to use what we have. We have O as the center. We have a tangent. We have a perpendicular line. Perpendicular lines. All right. Now let's start here at the center. What about the center? All right. What about the center? We know that a line from the center is perpendicular to the chord. There is no chord here, right? So it means there is no theorem one. Line from the center perpendicular to the chord, all right? There is no theorem one. The second theorem says angle at the center is twice angle at the circumference. Let's look at any chord or any arc. Let's look at any chord. They said PB is a AC. AC is not a chord, all right? Uh, look at PB. PB is a chord, right? So PB is a chord that subtends an angle at the center, which is angle O1, right? So angle O1. Now let's look at PB. B subtends an angle where? At the circumference now. And also this one, the circumference now. So now, you all agree with me that angle O1 is twice angle A1, right? We collect that one. Angle O1, it is twice angle A1. We know if this one, you know the reasonings. Angle at center is twice angle at the circumference. All right. Now that I know this is twice of this, let's see. Let me do this. Center, theorem 3. Let's say theorem 3 said, all right, another theorem with center, it is theorem 9 that says, is it theorem 9 or 8 that says line from the center? If a radius, remember radius, it is line from the center to the circumference. It is perpendicular to the chord at a point of contact. Perpendicular to the chord at the point of contact. So it means now this angle, it is 90 degrees. So it means what? Angle P1 plus 37 degrees, it is equal to 90 degrees. Why are we saying that? Tangent perpendicular to radius. Did I say chord? So this plus this, it is equal to 90. Why? That angle, that reason. Therefore, angle P1, it is now equal to how much? To 53. We haven't looked at the question. Then, all right, I'm done with the center. Let's go to the tangent. Already I used a theorem that included tangent. Let's look at another theorem. If I have a tangent and a chord, in this case my chord, it is PB. They say, the theorem says an angle between a tangent and a chord, it is equal to an angle subtended, it is equal to an angle that the chord subtends at the circumference. The chord PB subtends an angle at the circumference. So you all agree with me that this angle here between a tangent PN and a chord PB, which is 37 degrees, it is equal to the angle that the chord PB subtended the circumference, which is A1. So we can say a angle A1, it is equal to 37 degrees. Why are we saying that? Tan chord theorem. And now when you rewind back, there is something about A1. You must just substitute O1. All right, it's fine. So now that I know this is 37, and I know this is twice 37, I can say this is now how much? 74 degrees. All right. Let me see another thing. And I can, if I, oh, perpendicular lines. If this is perpendicular to the of, I'm already given that this is equal to 90. Therefore, I know this is also equal to 90 here. So it means angle O2, um, angle O2 here, it is equal to 90 minus 74. This one is just a perpendicular lines. 90 minus 74, which is equal to 16. All right. If that's 16, another thing that I can see, yeah, that's all, perpendicular lines. But please look at this. This is a diameter. So I think the examiner forgot to tell us that we have a diameter there. So we just collected that we have a diameter. What about the diameter? An angle that a diameter subtends at the circumference, which in this case it is uh, B2 plus B3. It is what? It is equal to 90. So we can collect that to our data and say now to us angle B2 plus angle B3, it is equal to 90 degrees. Y angle in the semicircle. Alright, so we now know this is 90. Here it is 90. Yeah, yeah, that's all I can see. That's all I can see. All right. 10.1.1. Determine giving reasons the angle of O1. The angle of O1, right? So the angle of O1 here, I know angle O1 it is twice angle A1, right? But the question is, do I know angle A1? No, I do not know angle A1. So it means I should start by finding angle A1 first. But I know angle A1 it is equal to what? It is equal to 37. Why? Tan-chord theorem. All right, let's start there. When we answer, we're gonna say 10.1.1. Start first by finding angle A1. We say it is equal to 37 degrees. Why are we saying that? Tan-chord theorem. All right, but we know that angle O1 it is twice angle A1, twice angle A1, which in this case it is 74 degrees. What's the reason? Angle at center, it is equal to twice angle at circumference. All right, that's your 4 marks. 1 mark statement, reasoning, statement, reasoning. 10.1.2, 10.1.2a. It says to us, prove that OAC is a cyclic quad. OAC B. Prove that this is a cyclic quad. Remember, how can I prove that something is a cyclic quad? First property, bow tie shape. This is the first property. Second property, the angles that I'm adding here, opposite angles are equal to 190, or as long opposite angles are equal to 190, right? Ah man, 180, sorry about that. The third one is that I have an angle and an exterior angle. This angle should equal to the opposite interior angle, which is in this case that one. So if I see here, reverse. If I see here, I see a bow tie somewhere, somehow here. All right, we all agree. We all agree. If I were to do this, you all agree with me that I see a bow tie shape, right? And do this. You all agree. This is a bow tie shape. So let me try and prove a bow tie shape. A bow tie shape says to me, let's use this 90. Why does this 90? This 90 seems like it has something. If this is all right, according to bow tie, says this angle O3 should equal angle B1. This angle should equal angle B1. This is bow tie. Or this angle should equal to that angle. Or this angle should equal to that angle. Or what? But when I check this part, I have information about O3. Right? I have information about O3. And in this case, we are saying O3 it is equal to what? O3 it is equal to B1. So let's try to prove that angle O3 it is equal to B1. How can we do that? All right. Um. All right. I know this angle here. It is 90. Right. If I know that this angle is 90, here is a reasoning why I'm saying it's 90. I'm not adding this up. If this angle is 90 and this is a straight line, I know this whole part should equal to what? 180. So it means angle B1 also it should be how much? It should be 90. And if angle B1 is 90 and O3 is 90, angle in the same segment, I'm done. I don't even need to look at the other thing is they're off. I'm done. Did you hear me? All right, let me do what I was saying there. I am saying now let's prove that angle O3 it is equal to angle B1. How can we do that? The first thing is that we know angle B2 plus B3 is equal to 90. Angle B2 plus angle B3 it is equal to 90. Why are we saying that angle in the semicircle? Right? But since angle B1, B2, B3 are angles on a straight line like this. This means if this is 90 here, if this is 90 here, reverse, reverse. If this angle is 90, it means the remainder of the angle should also be what? 90. Therefore, you're going to say angle B1 it is equal to 90 degrees. Why are we saying that? Angle on a straight line or adjacent supplementary angle. Adjacent supplementary angles or angle in straight line. Angle on a straight line or angles on straight line. Therefore, angle B1 it is equal to angle C3. Was it C3 or O3? Angle O3. It is equal to, they are both equal to 90. Right? If that's the case, then therefore, we can say whatever, therefore, if they are equal, actually, whether they're equal to 90 or whatever the value, if they are equal, we can say OACB. OACB is a cyclic quad. What's the reason? Remember, you should include a reason. The reason you're going to say Remember here you cannot reason. What if you were told that it is a cyclic chord? What's gonna be your reason here? Your reason was gonna be angles in the same segment, right? But remember, in this case, you're trying to prove. So you're gonna say converse angles in the same segment. You are trying to prove. All right. This is your reasoning. Converse. When you reason for the proof, you say use converse. All right. Then let's look at the last question, which is number B. Says to us, all right, let's see let's do this. We know now this is 90 here. All right. All right. That's fine. Let's try to hear this question. Prove that OC is parallel to PN. OC parallel to PN. OC. I like to do this. OC parallel to PN. All right. Now I like to do this. Let's do this and see. If we can prove that angle C2 it is equal to 37, then these lines are parallel. If we can prove that C2 it is equal to 37, these lines are parallel. Now, how can we do that? Let's go back to our bow tie. All right, this is my bow tie. What does my bow tie say? Angle A1 it is equal to angle C2. This one we already proving. This is 90, right? Angle A1 is equal to angle A2. But what is angle A1? Angle A1 is 37 here. And angle C2 is going to be how much? 37. So if it is 37 and that is 37, it is proven. Geometry sometimes can be so nice. There, I'm not saying it is easy. I'm saying it can be nice. So we're going to say, all right, angle C2 it is equal to, I'm going to come here and say angle C2 it is equal to angle A1 it is equal to 37 degrees. Why? Angles in the same segment. And say therefore angle C2 it is equal to angle P2. Actually, if you have proven that angle C2 it is equal to 37, therefore those two lines are parallel. Therefore, which two lines? OC is parallel to PN. What's going to be your reason? Your reason is going to say converse alternating angles, or you can say alternating angles are equal, or you can say converse alternating angles. Is there any other way we can prove this? Let's see. Let me see if I have time. All right, I still have time. Let's see. Is there a way we can prove this one? All right. Using this part here. All right. If you can prove that, remember this we are given as 90, right? Let me do this so that I do not hide the angle. This is 90. O3 is 90. If I can prove that this whole angle here, it is 90, then these two lines are parallel. Why? Converse alternate corresponding angles. But let me check. P1 plus P2. Anywhere P1 plus P2. P1 plus P2. Here it is. Here it is. P1 plus 37, it is equal to 90. Why? Tan perpendicular to radius. Therefore, these two are corresponding. Then we are done. Or you can say, let's call it APN. APN, meaning A APN, this angle here, this one, APN, let it become equal to 90. Why? This is a line, this is a radius, and it is perpendicular to the tangent. So I'm gonna say APN, A angle PN, it is equal to 90 degrees. Y tangent perpendicular to radius. Therefore, OC is parallel to PN. Why am I saying that? Corresponding angles are equal, or I can say converse corresponding angles. I'm done. So yeah, that's all for today, folks. Thank you very much for watching my YouTube video, and please, if you liked the video and enjoyed it, please kindly subscribe to our YouTube channel and don't forget to give it a thumbs up. Thank you.